In this section, let's perform an FTP-based installation of FreeBSD. So we'll log in as root to our recently installed FreeBSD instance. And this gives us a shell. So if config will tell us that we have an IPv4 address of .40, and we can then connect to our FTP server to set things up. So let's send a few packets over to our FTP server 75101. So it responds. So from there, we'll ensure that the ISO image that was used to boot the system is available via anonymous FTP. FreeBSD may also be installed using normal account-based FTP. You'll simply have to specify during the installation that you'd like to authenticate as a named user with a specified password. But for simplicity, we'll use anonymous FTP. So let's SSH to the remote system 101. This is a Debian box. It's the first time we're connecting, so the SSH client prompts us with the fingerprint, the SSH unique fingerprint of the remote host. If we accept it, then we'll be prompted with the password prompt to authenticate, at which point we'll have a root session on the remote system. So now we're logged into the remote system. Its name is Linux CBT build 1. And its FQDN is Linux CBT build 1.linuxcbt.internal. Anonymous FTP on Debian systems is served from, in this case, Debian 6 system. Let's cat etc Debian version to see what version this is. 601 is served from serve FTP. So in this directory, we've placed FreeBSD8 release AMD64 disk1.iso. This file is about 691 megabytes. You can download this file from ftp.freebsd.org. And you'll find it in the ISO images directory for the AMD64 platform. You'll also find a DVD image file, which is about 2 gigs, which contains compiled binaries, all of the ports, all of the documentation. This is the ISO image that we've been using all along to install our system. So it contains the ports, which is 400 and something megs, but then expanded to a larger size, as well as the documentation and the base system. So this is enough to get our installation going. We've also downloaded from the FreeBSD website the boot ISO image, which is about 50 megs for this platform. In fact, if we lftp to ftp freebsd.org, we might be able to have a quick look at the directory structure on the remote system since it supports anonymous FTP. Let's see if it connects us out. We'll be able to take a look if it lets us in, and it seems as if we've connected. So now let's take a look at the public tree, FreeBSD, and we're running the current version 8.2, which may be a newer version. Now there are ISO images linked for each of the various releases. So let's take a look at the releases directory and into AMD64. And from here we'll see ISO images for 8.2. So in ISO images we'll go to 8.2. Might be a later version, a newer version by the time you install it, but by and large it's largely the same, minus a few changes. So here are the ISO images that are available. So just to recap, we've been installing all along from AMD64 disk1.iso. This is the 691 megabyte file, which translates to 724, etc. However, there's a DVD1 image file which contains much more information, all the documentation, all the ports, as well as many compiled packages. There's also a live FS, or live file system ISO, which allows you to boot directly from the ISO image and have a fully running FreeBSD system. There's also a memory stick image file which can be used to install the system from a memory stick as well as launch a live FS. So to recap, we're going to now reboot the system using this image up top, AMD64 boot only ISO. Notice that it's about 50 megabytes. This is 53145/600. This is enough to get us booted to the point where we can then point to a remote source such as an FTP site for the remainder of the files. But it requires that the FTP server is set up, and preferably in anonymous mode to reduce the installation requirements. So this is ideal if you're installing many FreeBSD systems within your intranet environment and then you like to do it, have it perform quickly and not use the internet, so to reduce your bandwidth utilization. So you download the ISO image once, mount it on an internal FTP server, and then boot with the 50 megabyte or so ISO image to perform your networked installations. So we have the AMD64 boot-only ISO ready to go once we reboot the system. And we also have in serve FTP the file that we've been using all along to boot the VMware instance, which is about 691 megs. But this is not enough to be able to install the system. We have to mount it and make it available in our FTP server as a directory structure that mimics the FreeBSD website. Now what we're going to do is mount it into a directory called temp and then create a directory structure called FreeBSD and make one change so that the installation doesn't fail. This may change by subsequent releases, but for the current ISO image, this is what's required. So let's make a directory temp. We now have temp. Let's mount ISO 9660 FreeBSD into the temp directory. When we then change into the temp directory, we'll see the structure. The one change that we'd like to make so that the installation doesn't fail, as we've already tried, is to move the packages directory into the 8.2 release directory. Otherwise, it fails when the installer sysinstall attempts to find packages beneath 8.2 release. One way to handle this is to create a symbolic link. Another way is to simply move the directory. But because this is an ISO image, which is akin to a CD-ROM or DVD, we cannot move the item within the ISO image without recompiling the ISO image. So the thing to do is just copy the contents of the ISO image into our FreeBSD directory, which we've yet to create, and then shift things around. So let's make a directory one level up, labeling it FreeBSD. Then let's copy APVF, which copies everything, preserving timestamps, into FreeBSD, followed by a change into FreeBSD, followed by an LSL. Now this uses the bash feature, which allows commands to be executed if successful, one after the other. So the copy will take place, and if it's successful, we'll then change, our shell will change us one level up into the FreeBSD directory, and if that's successful, it'll enumerate the contents of that directory. So let's go ahead and perform this. It's only 691 megs, so it shouldn't take too long, although it isn't so much the aggregate size, but also the number of files that need to be copied that can cause the I/O process to run slowly and take longer than it normally should. So that's been copied. Now we're in the directory. If we do a DUCHS, for example, you see the 693 megs. So now our next change is either to symlink the packages directory into the 8.2 release directory, or just move packages into the 8.2 release directory. That fixes the little issue that we ran into. Now before we reboot our system to test that this all works, let's connect to our local system as anonymous. So we'll LFTP anonymous at localhost. And we'll just make up any password. And once connected, we should be able to see the FreeBSD directory. And let's see if it picks up the phone. And it's actually taking a while. Let's do a netstat to see whether or not it's listening on the loopback adapter. So netstat ANT or NTL, grep21, and it's listening to all IPv4 addresses. Let's try that again. We'll FTP anonymous at localhost. Let's see if it picks up. Let's just try it with localhost. It's not parsing it out. Anonymous. And finally we're in. So now, here's the directory structure that sysinstall will see. It'll see the ISO image, but that will do it no good. It'll also see the temp directory, which we can remove. And it'll also see the FreeBSD directory, in which it'll find all of the files needed. And there are the items. So let's exit. So to clean things up a bit, we can remove the temp directory, but we have to unmount it first because currently it is mounted. So let's umount temp and then remove rf temp. So now it's a bit cleaner. We can also remove this ISO image, FreeBSD, because we've copied the contents. So let's remove RF just to avoid any additional confusion. Now we're clean. We have a FreeBSD structure which represents 8.2. For future releases, this can also be used. Simply create the new release directory, such as 8.3/release that is in the FreeBSD directory with its contained packages folder or directory, and that'll work. So now the FTP server is set up to serve us, and our VMware instance is set up to boot using the boot-only image, which is only 50 megs. So if we reboot, this should work. So let's reboot, not the remote system, but our local system. This will shut services quickly, syslog included. So let's continue our installation. After the reboot, this will prompt us momentarily. We'll select option 1, and this will load sysinstall momentarily, at which point we can navigate through the common setup. The partitions that were laid out before will already be in place. We can reconfigure them if we'd like, or keep them and have FreeBSD use them since they're already laid out. So custom installation. Take a look at the partition, and to select the various disks, you can press spacebar to select the given disk. So here's the slice on DA1, Q to quit, no boot manager, and space on DA0. There's the slice on it. Boot manager, that's a default. So DA0, DA1, and let's continue. Now let's check the partitions, or check the labels that is on the various partitions. And there are the labels. Now notice there are no file system laid out on both of these disks. We can toggle the file systems if we'd like by changing the option, but currently, because it's set to asterisk, we don't have that option. So we can make the change by just deleting and recreating them. That's one way to do it. We can also set the mount points by using M for mount point. So for example, for this partition, it would be root, and it's set to UFS. If we remember the allocations, that works. M, this is user, recall, is 7.2 gigs. And this is partition D on the first disk. So it's a gig swap. So swap remains the same. 3.9 gigs for another partition EF9. So we need to determine what should be allocated where. So we have 4 1 gig partitions, of which one is swap and a 4 gig partition. So we should definitely lay out one for temp. So let's call this one temp. The order is unimportant, so let's make this a mount point of /temp. We also had var as a gig, so let's make this /var. And we also had opt, so let's configure this one in the event that we install third-party applications, leaving this for home. So mount point /home. So 4 gig home, 7.2 gigs roughly, 7 gig home, user /user. So this looks good, and let's go ahead and commit the changes using Q to finish. Distributions, we want everything. So spacebar all, this will install all of the ports to allow us to take advantage of those applications. The media, this is the important part for the FTP installation. Now, whether or not your server uses passive or port is something you'll need to look into. So let's go with FTP passive. And here are some options that are available to us depending on where in the world you exist and which protocol you're using, IPv4 or 6. Most of the options are for IPv4. The main site is ftp.freebsd.org. However, we have an internal server set up, so we'll select URL. So let's press enter and indicate the IP address followed by FreeBSD. That's the directory structure. From here, sysinstall will be able to find all of the directories and files that are necessary to complete the installation. Of course, we need to configure the network interface. We can also assign IPv6, although it won't be used for the installation. But IP is important, of course, if we intend to perform a network installation. So let's label the host. This is UCBT1. As we've mentioned, you don't need to specify the domain part there, although it's copied over in either field you place it. The gateway is 1. The name server is 101. The address of this host is 40. and that should get us going. So now we're ready to commit the changes. This is our last chance. Now using existing root partition, it knows that it's an existing partition. It's just a way to warn, to tell us that we could run the risk of losing data. So it's a caution. Let's see how we're looking. So it's doing a check in FSCK to ensure that the file system is consistent, because we're reusing file systems. Had we provisioned the file systems anew, this check would not be run. So it's a due diligence to be sure that the operating system is being installed to a hard drive that has proper sectors. Holographic shell VTY4. Now it's extracting the base. Now if we have access to the FTP server, we could run a watch of the tail of the log file for the FTP server. So in the case of Debian with VSFTPD, it would simply be a watch space tail space /var/log/vsftpd.log. You could put a timer in there such as 2 to refresh every 2 seconds or so. You'll also see that the majority of the fetches from the FTP server succeed. Every now and again you might see a failure in sysinstall's ability to pull files from the server using the FTP client. So sometimes you'll see a fail, but the majority of the requests should be succeeds or OKs. And you can always look into the paths that are true that the client is trying to access. Sometimes it tries but then stops and looks for something else. It depends on what sysinstall is looking for at the particular point that may determine whether or not a request fails. But overall, the installation works so long as you either symlink packages beneath the release directory 8.2, 8.3, 9.0, etc., or you move the packages directory entirely beneath the 8.x release directory. So this is pulling in the various packages. This happens to be the one for English. So that's how you affect an FTP installation. Now, had we tried to install from CD, sysinstall would prompt us for a proper CD. So perhaps the ISO image, the almost 700 megabyte ISO image that we have previously used for installation, or the DVD image. Otherwise, this particular image, which is 50 megabytes, represents a stub. It doesn't contain the requisite code to install FreeBSD. So just keep that in mind. Very important. So we should be back up and running momentarily. Now again, because it's a custom installation, at the end of the process, we go through some checks such as setting root's password, defining the initial non-privileged user, Unix CBT, which is indexed at 1001, which means subsequently created users will be indexed at 1002 and onwards. But users are indexed at 1001 onwards on this particular system. Some Linux distributions index users at 500 and above, many at 1000 and above. So it's similar with FreeBSD. So the worlds are closer than they are apart. So once those are set, networking is set, we can then reboot the system, and we're brought up, of course, in text-based mode. Once we're up in text-based mode, we've confirmed our partitions, we know that everything's intact, we can communicate with the network. We then overlay a graphical environment to make the environment a little bit more tractable. So this is a custom installation with a number of partitions for user, home, var, temp, opt, a swap partition that's roughly twice RAM, etc. Now if the RAM changes in the system, then you should also change the swap. So if we add, say, since this is a virtual instance, we're free to assign as much memory as we have available to spare at any time by simply rebooting the system. So if we up it from 512 to 1024, then we should up the swap from 1024 or roughly a gig to roughly 2 gigs. In the swap section, that's what we'll do. We'll add additional RAM, which will mimic adding physical memory to a real system or provisioning virtual memory, let's say for a virtual instance such as Amazon EC2 or VMware or any other type of virtualized solution. So long as you provision more random access memory, you should be prepared to have double that in disk space for swap storage in the event that it's necessary. Now, oftentimes with ample memory, swap is seldom used, which means you'll seldom suffer from those performance hits experienced by the operating system as a consequence of degrading from the speed of RAM to the reduced speed of disk I/O, as it's considerably orders of magnitude slower. So this is moving along nicely. Again, our consoles are still available. So regardless of the installation type, whether it's FTP across the wire or via local media such as CD-ROM, it operates similarly. As we've mentioned also, if you recall from the ftp.freebsd.org website, there's also a memstick.image for A.X, in this case 8.2. That is an image file which can be dumped using a program such as DD to a USB stick, and so long as your BIOS supports it, which in the case of VMware it does, but if your physical system's BIOS supports booting from USB, then you can boot from that memory stick. It contains a live FS, which means you can run a live implementation of FreeBSD without installing it directly from the USB stick, which has various advantages, which means you don't have to go through the process of installation and configuration. And you can sample FreeBSD to see how it works for you. And you can also install FreeBSD directly from that memory stick. So it's a portable way of moving the operating system around, trying it on different hardware, installing it where applicable, and becoming part of the FreeBSD community. So this is extracting currently scontrib, etc. So our ports are definitely being set up. And as we've mentioned, insofar as the ports are concerned, there are thousands of applications that are available that, if you're familiar with Linux, you will definitely see ports or applications that are quite familiar. Below each of these packages that are being installed, we see transfer information, so the rates of transfer. Sometimes they appear to be slow, and that's because we're doing so many small files. So many small files are being copied. So that's why it appears to be slow. This I/O is taking place across the wire, so as fast as the wire will deliver is as fast as it'll be copied, with other bottlenecks to take into consideration. So sometimes you'll see rates as fast as 10 megabits per second, maybe a little bit more, and as slow as 50 kilobits per second. It depends. It depends on the number of files, the current network availability, the system's utilization. In this case, it's virtualized, so depending what the host system is doing, insofar as other tasks are concerned, including, of course, other virtualized instances. So a number of factors at play which can determine the exact transfer rate and performance at any given time in a virtualized environment. Same applies for physical to some degree. Let's see how we're looking on the other console. This is user SBIN being set up. Now, insofar as the FHS or file system hierarchical standard is concerned, FreeBSD follows the standard FHS that Linux follows. So you'll notice directories such as user, bin, being off of the main root, as well as sbin, user sbin, etc. So those are all part of the FHS spec. So if you see /bin and sbin, those are required binaries, system binaries and common binaries. If you see user sbin and user bin, those are not required or not mandatory binaries. They're useful, but not required in order for the system to start. So the Unix hierarchy is laid out in such a way so that it's clear to us as administrators which directories are important and which are simply ancillary and can be omitted for the sake of booting the system into an operable state. Let's see how we're looking over here. So this is now doing the ports sys utilities. Number of items are being copied, so this should be clean momentarily. And because it's a new install, when it comes up, it generates a new SSH key that's unique for the public key pair that's used at that particular point, and subsequent SSHs from other clients on the wire into this FreeBSD instance will prompt to accept that new public key for the sake of securing communications between the SSH client and the SSH server. So this is looking good. So this is an FTP-based installation that is customized with partitions that suit our need. Again, if you have a SAN or an iSCSI SAN or NAS that you'd like to connect to for the sake of running specific applications, this mere skeleton would work. You could have two 8 gig partitions to run the system and then connect to the SAN to run your specified applications, perhaps Apache for content serving or MySQL or PostgreSQL, etc. That's certainly not an issue. One caveat or one thing to always be concerned about, however, is the var partition. Var, often on busy systems, becomes very big. Even with log rotate, compressing and rotating or rotating and compressing log files. So it's often advised to offload var to its own disk and then to back it up and to have syslog dump the data to some sort of backup log host. It's always a good idea in a networked environment to have one or more log hosts that everyone directs their traffic to, so that in the event that a system is compromised either by an external person or some other extenuating circumstance such as power failure, failed component such as hard disk, etc., you should have the bulk, if not all, of the records on some other host. So I like to set up, for example, 2 log hosts running syslog or syslog-ng, and then point every single system, Windows and Linux and Mac OS, to those systems in a protected VLAN to dump all of the records. Syslog-ng tends to work out a little bit better because they can all the systems can share the facilities, but syslog-ng can then parse the incoming IP addresses and then route the traffic that way, so that you have one place or 2 places to go to find all of the log data concerning all of your servers. So we'll ignore the last second options. This looks good. We can cancel. Again, it's custom, so it doesn't guide us step by step. Let's do some post configuration. So for example, insofar as the root's password, let's set that once again. And that's set. And let's define the first user, which is case sensitive, by the way. And this is Unix CBT user 1. Give us some room to define some other users. We don't need any groups for now, so we'll just exit. The time zone we should set. It's set to UTC so that the time is correct when the system comes up. Let's page down to the United States, Eastern time zone. Set yours appropriately. Mouse and so on we can ignore. Networking is already configured. If we go to interfaces, you'll see it's already hardwired. It keeps it from the installation, so that need not be set or reset. We'll ensure that it's up. Let's exit. And this looks pretty good. So let's exit. And at this point, we've again installed FreeBSD. So we can exit the installation, have the system reboot. So let's go ahead and do that. And of course, it's always important to ensure that the system doesn't boot from the ISO image or from the CD-ROM, which we have a dip switch to control. So it makes it easy for us. You can toggle F5 from here, for example, to go from the drive. PCI bus detection, USB, etc. Like Linux, FreeBSD loads drivers for commonly found components, floppy disks, or floppy drives that is, USB devices, hub devices, etc. Now we're back up. Key wasn't generated because it didn't reformat the drive, so it used the settings that are there. But it did reset things like the user's password, etc. So let's see, df-h, and there's our layout. So things are slightly rearranged, but we're back up, and if config should tell us we have 42 packets over to the gateway or to our DHCP server, and that's in business. So we're back up. Custom installation, let's just check that our consoles are available. You can see the TTYV numbers changing. Of course, F9 is not available because we don't have X currently installed.